Okay. Hello, everyone. Can you all hear me okay, or can anyone hear me? We're just getting everything set up here. Going to be starting shortly. Sounds great. Okay, cool. Yeah, this is kind of like informal. I wanted to catch up on some AWS news and announcements, and instead of just reading it by myself, I figured let's go through it as a group. So we're going to spend some time looking through some of these. I'm not going to read through all of these announcements. There's like a lot of stuff here, and typical with reInvent coming up in a couple weeks, or I think 2 weeks. There's tons of stuff being released here. Once we do that, we're going to read this blog post, which is by Werner Vogels. Lambda just turned 10, so it was launched about 10 years ago. And so he's got some commentary where he introduces it, and then we're going to kind of skim over the blog post itself, which he has down here, and just kind of talk about the things that are interesting as part of it. So that's the agenda. So let's just get right to it. And if anyone has any requests of like things that they want me to talk about in terms of AWS news, feel free to let me know. I do have like a bunch of videos coming up. I've released a few, one on the S3 1 million buckets, another one on DynamoDB's price drop, and then another one coming out next week on Monday on Aurora serverless, or like real Aurora serverless now. So you can look forward to that, but let's go through what we have here. So first one up, simplify Amazon VPC security groups with VPC associations and security group sharing. Oh, this looks interesting. I think what they were trying to do here is that maybe security groups they only existed, like you can only create them on a single account, like you couldn't share them across account. But let's check this one out really quick. By the way, this is the website. Oop, sorry, I just heard a beep. Uh-oh, you guys lost my video. 1 second. Let me figure this out. Hold on. Okay, did that work? Yes, okay, I'm back. I may have to disable video actually at some point because my camera is kind of finicky when it comes to live streams. Anyways, yeah, I'm saying it was on this website, AWS News. It's got a lot of good content here and also some summaries. They use some like AWS, or not AWS, but some like LLM to summarize it. So let's just check this out really quick. AWS introduced 2 new features for Amazon VPC. Security groups to simplify security management across multiple VPCs and accounts. Security group VPC association. So allow creating security groups that can be used across multiple VPCs. Oh, that's what it was. So it wasn't same account, but if you create a security group, it was scoped to just that VPC, which is kind of annoying actually if you have multiple VPCs to deal with. So that's something new. Security group sharing enables sharing security groups with participant accounts in shared VPCs within an AWS organization. I don't even know what this means. I don't use AWS organizations that much personally, but some of you might. If you know what it means, let me know. Key benefits: ensuring consistent security rules across workloads, fair, simplifying security group configurations and maintenance. Okay, so making it easier to configure across VPCs. Reducing overhead of managing multiple security groups and configurations. Okay, this one's kind of a nice to have quality of life. Oops, don't want to do that. Quality of life improvement, but not something that is going to change too much. Okay, cross account, data store read access for AWS Health Omics. That doesn't seem very interesting. We're going to skip that one. Fundrise uses Amazon S3 One Zone to accelerate investment data processing. This looks to be like a use case blog post, but also not something worthwhile. Application load balancer introduces certificate authority advertisement to simplify client behavior using mutual TLS. Not something I care about personally. Commercially available discovery tools. Where's the interesting stuff here? Ooh, this one looks good. Amazon EC2 auto scaling introduces highly responsive scaling properties or policies. What's this? EC2 auto scaling has introduced 2 new capabilities to improve scaling policy responsiveness. Target tracking policies now automatically adapt to individual application usage patterns. I can't remember. Wait. I think I have to read the actual article for this. Ability to monitor high-resolution CloudWatch metrics for more timely scaling decisions. Okay, so there's less than 1 minute CloudWatch metrics available, and I think previously it was only looking at 1 minute, so this looks to be changed. Particularly beneficial for applications with volatile demand-like APIs, so like really spiky workloads, so you're going to be able to scale a whole lot faster. Self-tuning policies optimize the balance between cost and performance. Okay, so this is like kind of automated policies to, looks like, try and predict increase in workload and predict decrease so that it can scale appropriately. And then it's available in select commercial regions and configurable through AWS management. Okay, fine. Next, anything good here? Find security, compliance, and operating metrics in AWS Resource Explorer. Who cares? Performance gains in Amazon Q Developer Agent for code transformation. Also, who cares? OpenSearch ingestion now supports writing security data to Security Lake. Who cares? Create custom shape maps. Who cares? Boost productivities with imported visuals in Amazon QuickSight. Don't really care. Custom charts in Amazon QuickSight using high charts visual. Wow, there's like a lot of garbage here. Elevate your dashboards with font customization. Wow, font customization. Great. Like really a whole blog post for that. OpenSearch ingestion now supports AWS Lambda for custom data transformations. Ooh, this looks good. What is this? OpenSearch ingestion now supports AWS Lambda for custom data transformation, providing new capabilities for event processing and routing of streaming data. Customers can define Lambda functions in OpenSearch ingestion policies. You know what? I want to read the article here. Oh, it's just kind of like a basic blog post. Okay. OpenSearch now allows you to leverage AWS Lambda for event processing and routing, enabling. Okay, we just read that. Customers can now define custom Lambda functions in their OpenSearch ingestion pipelines for use cases like generating vector embeddings and lookups in external databases to power advanced search use cases. Can now define custom Lambda functions in ingestion pipelines. So I guess this means like when you're taking in data into your OpenSearch, you can have a Lambda in between like whoever's delivering it and when it gets ingested into your OpenSearch so that you can like transform it or format it in a specific way that's useful in OpenSearch. Gives you the option of either using only Lambda functions or chaining Lambda functions with native data prepper processors and transforming data. You can also batch events into a single payload based on event count. Okay, so you can say how big your events or how many events you want to process at once, it looks like, and size before invoking to optimize the number of Lambda invocations to reduce cost. So there's a cost improvement element here. This is kind of like DynamoDB streams, if I'm thinking about this correctly, how you can attach a Lambda function to it. Furthermore, you can use this feature with the inbuilt conditional expressions in Amazon OpenSearch ingestion to enable use cases like sending out emails and notifications for real-time alerting. Okay. It's available in 15 regions. All right. Nice little feature there. What else is here? Improve visual capability. Who cares? Security, compliance, and operating metrics. Dissecting the performance gains. Did I already read some of these? boost productivity with imported visuals, custom charts. And yeah, I already read some of these. What's going on here? I think we stopped here. Layer map, a lot of QuickSight stuff. Lambda announces provision mode for Kafka, event source mapping. Interesting. I don't use Kafka. Oh, this one's good. I heard some really good things about this. For those of you that use step functions, AWS step functions simplifies developer experience with variables and JSON data transformations. Oh, this just sounds good. I'm just going to go straight to the article. Do they have like a... Yeah, that's what I want. Are you guys able to see this, though, is the problem. How can I fix this? Maybe this way. Sorry, I'm just waiting for it to load on my actual live stream that I have in the background running here. Okay, there. Yeah, you guys can see this. Cool. Let's see what this says. So simplifying developer experience with variables and JSONata. Okay, and AWS step functions. AWS step functions is introducing variables in JSONata. I don't know what that is. Data transformations. Variables allow developers to assign data in one state and reference it in any subsequent steps. Oh my God, yes. This is good. Simplifying state payload management without the need to pass data through multiple intermediate states. Oh. With the JSONata, an open source query and transformation language, you can now perform advanced data manipulation and transformation, such as date and time formatting and mathematical operations. Wow. This is really good. The blog post explores the powerful capabilities of these new features, delving deep into the simplifying data sharing access, states using variables, and reducing data manipulation complexity through advanced JSONata expressions. I don't know if I'm pronouncing that right. Let me explain this to you, because this was a massive pain in the butt. If you've ever used step functions, which if you've never used step functions, you probably should consider it because they're amazing. I also have a course on step functions, which you can check on my website. It's courses.beabetterdev.com. Anyways, let's talk about what happens. So step functions, you basically like define these nodes, right? And you can say, you have these different tasks that you could perform at different states here. So you can have like a Lambda in here. Lambda. Wow. Let me just do this bigger. Actually, this is dumb. There we go. Lambda. And then there's also like an input step, right? Where you can provide some kind of data as your input. And this can be like some JSON object with some payload, right? So some keys and values, and that's used to kind of determine how your step function works, right? And then like say your Lambda takes this input and like internally, it calls some database, right? Calls some database. And then maybe it does like a bunch of things with that data. Maybe it transforms it. It does a couple other things, okay? And then you have other stuff that needs to happen after the Lambda function. Maybe you have what's called a choice state. Choice. And with this choice state, you can effectively say like, if some condition is X, then go in this direction. And if some condition is Y, then you go in this direction, right? And so what previously had to happen, like say you have other things that you do after this. Previously, what you had to do is like, if there was some data, some important data that you returned back to your Lambda function, and you wanted to pass through to your choice state, you had to like write it as output. Right, so you have to write that data as output into from your Lambda node. So that would then need to go to the choice node. And then if you want to use it anywhere else down here, like in any other states for your step function. And keep in mind, these things are usually like pretty long. It's not uncommon to have like 10, 15, 20 plus states in a step function. What would happen is that you would need to basically carry it down, right? It's kind of like in a recursive function where you need to like carry down in the function arguments. If those of you that know what that means will get it. So you would need to carry down this data that you retrieve from any state above it. Okay. And this was really annoying because the language to do this, it like uses this ugly JSON path kind of syntax that you would need to do. And so you basically need to do all these redundant operations to carry this data down, even though it's just kind of being passed forward. So now, based on what I've gathered from this blog post, it looks like you can say, like, when you retrieve the data at the Lambda function, like right here at this point, you can assign it to a variable, like maybe it's, I don't know, customer order ID, something like this, order ID. And then instead of carrying it down like we were seeing, right, you don't necessarily have to do this anymore. You don't need to carry it down and send it all the way down and anywhere else. In any other state that is below the Lambda function, in this case, you can access it. So you can access it in this choice state. You can access it here. You can access it here. Anywhere else, you'd be able to access it. So really, really handy and helpful quality of life improvement, if I'm understanding this correctly. I haven't read the whole blog post yet, but we can just kind of skim through it right now. Yeah, let's do that really quick, actually. And yeah, so we read this. Okay, overview. Step functions, yeah, you can build workflows that involve multiple services, such as Lambda, blah, blah, blah. Within these workflows, you build states to interface with these services, passing input data and receiving responses as output. While you can use Lambda functions for date, time, and number manipulations beyond step functions, step functions intrinsics, that's what they're called. I forgot. So you can do like JSON path selections and like select the first element of an array to pass that down into the next state. These methods struggle with increasing complexity, leading to payload restrictions, data conversion burdens, and more state changes. This affects overall cost of the solution. You can use variables and JSON data to address this. Okay, how does this work? Consider the same business use case from the JSON path blog. We're not reading that. Customer onboarding process in the insurance industry. A potential customer provides basic information, including name, address, and insurance interest while signing up. Okay. This KYC process starts a step function with a payload containing these details. Okay, we just kind of talked about that. The workflow decides the customer's approval or denial, followed by sending a notification. So this is what the input to the step function looks like. Okay. And yeah, nothing unexpected here. Fine. The original workflow diagram illustrates the workflow without new features, while the new workflow diagram shows the workflow built by applying variables with JSON data. Okay, we can look at it. So what did they do here? So they're doing a parallel state. They're checking the identity, checking the address. So this is just some simple validation. They probably call some dependency here. Yeah, this is similar to what we just described, right? So then they have a choice state here. And if it's approved, they do some stuff in the database, send a message, publish something to SNS. And then if it's not, they deny it. Okay. Ooh. Now they have, whoa. So check identity and check address. Oh, this is that JSONata stuff. It looks like you can do like if conditions. Oh, this is crazy. This is actually really good. So it looks like you can do if conditions inside of pass state. So pass states, by the way, are just like placeholders. They don't actually do anything, but they allow you to manipulate the content that is passed in from the state above it. Okay. And so very, very useful. And that's how they're using it here, it seems. But I imagine they're going to describe this. They're probably going to use the JSONata, however you say it, syntax to validate some identity properties in the input. Same thing for address. And then you can see here, they give you a preview, something, and then is customer valid something. So I imagine they'll explain this. Okay. How does this work? Variables allow you to instantiate or assign state results to a variable that is referenced in future states. Okay. In a single state, you can assign multiple variables with different values, including static data, results of a state, JSON path or JSONata expressions, and intrinsic functions. The following diagram illustrates how variables are assigned and used in a state machine. So you get some input, and then they're interesting. They're defining a variable that somehow checks the contents of the input address and the identity fields. A bit unclear on like how that works. but it looks like you can do this using this new syntax. And then they're using it down here, right? They're using it in subsequent steps, which is pretty interesting. Okay. Okay, they're giving us an explanation of how it works down here. In step functions, variables have a scope similar to programming languages. You define variables at different levels with inner scope and outer scope. Inner scope variables are defined inside map, parallel, or nested workflows. Map, parallel, or nested workflows. Okay, what that basically means is anytime you see like a box like this one around a group, like anything in here is an inner state, and then anything outside of it is a outer state, is my understanding. Alternatively, you can set outer scope variables at the top level. Once assigned, these variables can be accessed from any downstream state irrespective of their order of execution in the future. Kind of like a global variable, but only accessible after the step that you're currently at right now. Cool. Variable assignment and usage. To set a variable's value, use the special field assign. Okay. The JSONata part of this blog post further down explains the purpose of %%. So we say assign, special syntax, input payload. Okay, we're assigning the variable input payload to the input. Oh, so this is how you do carry down. Okay. So basically what they're saying is that input payload is going to be accessible anywhere. Basically this picture here, right? Input payload is going to be accessible anywhere after the Lambda function. So that's how you do it. Hi, Justin. What is this? Is customer valid states.result.is customer valid and states.result.is address valid. But how is this determined? Is address valid? What was the input payload again? Okay, they just have address. So they're probably somehow checking for none. Justin says, this is going to make step functions so much better in less states IMO. It's totally true. And a lot of like less glue Lambda functions that are just a pain in the ass to set up for just a trivial data transformation. Blade Runner at Amazon was kind of like this. I'm not sure what Blade Runner is, but maybe you can let me know. Where were we? Okay, we were here. Use a variable by writing a $sign before its name. This is standard. Looks like you still have to use this JSONata expression. Okay, so you have to use this JSONata expression with the open squigglies and the percentage sign, in addition to the normal stuff that you have to do. Okay. JSON is a lightweight query and transformation language. For JSON data, JSONata offers more capabilities compared to JSON path within step functions. Man, I'm going to have to update my course now with this. Allows you to leverage JSONata with the state machine. Apply this configuration top level of your state machine at each task level. JSONata at the task level gives you fine-grained control of choosing JSONata versus JSON path. This approach is valuable for complex workflows where you want to simplify a subset of states and continue to use JSONata. Okay. What I'm really looking for here is how they actually define those like little mini functions. Yeah, like this check identity thing. Like how do you... Okay, here, I think this is it. So previously they had two Lambda functions that were doing some glue logic to figure out if, like to validate this, right? To like look at the input objects. And now they're saying you can do this in just states. So you're basically saving two Lambda function executions with every step function now. So there's some cost implications here. Okay, so they're using, okay, this is what the Lambda function used to do. So it was just a regular expression. They would test the SSN and test the email, okay? And if that's true, then they would just return return the state, right? This looks like it's a Boolean. So both of these must be true in order for it to be considered approved. Sorry, I just need a drink of water. Okay. With JSONata, you define regular expressions directly in the state machine's ASL. You can use a pass state and $match from JSONata to validate email and the SSN. Okay, so how does this work? So in the state, so in the output, so this is going to be passed to the downstream. We're saying is identity valid, and is identity valid is Okay, we're saying it must match. Oh, okay. Okay. So this is how, yeah, if you want to link to the article, here you go. So they're saying, they're using this match syntax that looks at this and then applies a regular expression to it, and then another match, and then doing the same thing. Okay, and it looks like there's some other ones too. So there's length, trim, each. I imagine you can do some like looping over stuff with this. Also not, wow, there's a lot you can do here. So not null in each. So each must be non-null, essentially is what this is saying for each. What? You can define proper functions in here? Okay, I need to learn about this. They got some ternaries too. Sweet. All right, I may make like a video out of this because this is very interesting. Some of the people at work, I think, can benefit from this too because we use a lot of step functions at work right now. Anything else interesting here that's worth talking about? Choice state becomes simpler to use with flexible JSONata operators and expressions as long as the expressions within dollar or pound percent, result in a true or false value. Got it. So you can assign this and then basically, oh, wow, this is crazy good. Okay. I'm not going to dwell on this too much. I think we kind of got the basics of it, but very, very interested in this feature. Let me know what you guys think, by the way. Oh, it's hard to read? Sorry. Should I zoom in? Is this better? I didn't realize. Let me know if it's too small, guys. Sorry about that. Let's close this out. Close this out. I want to kind of not dwell too long on all the AWS news because we can be here forever. Because I do want to read the Werner Vogels blog post on Lambda, and I think that's going to be an interesting one for most of you. Let's just skim over these really quick, actually. So, generative AI upgrades for Apache Spark. Oh, Justin's saying the logic introduced and how complex you can make it. Yeah, it's nuts. A lot you can do there. Q is now available as a browser extension. They enabled this at work, which is kind of crazy. It's like a little pop-up now that you have like right here in the side. It's a bit annoying. I noticed it the other day. So you can use Q as part of like your browser. It's all right, I suppose. I've been using Claude a lot lately, actually, and sometimes ChatGPT too. Q developer chat customizations available, fine. STS support, AWS, okay, who cares? Bedrock model evaluation is now available. Smartsheets, building reg. Okay, we already saw this. Syntax was convoluted, Madrag says. Yeah, I know. It looked really bad. Justin asked, do I use Q over ChatGPT? No, I don't use Q. I hope I don't get in trouble for saying that, but I've tried. Like I was planning on a course actually with Amazon Q. Quick side tangent here. I was working on making a course for Amazon Q, and what I decided to do when I was kind of initially doing it was that I was kind of playing with it with a project that I was working on, and I was trying it out, and it actually made me a worse developer and a worse programmer. And I plan on making a video out of this. I think there's been some blog posts of people sharing the same thing. But basically what happened was that I'll give you a very specific example. Part of the project I was working on was I was trying to write to Discord, right? I wanted to send a message to Discord, basically whenever something happened, to notify me of something. And so I was like, okay, like, this is great. Now I don't need to go and read the Discord documentation. I can just be like, hey, Amazon Q, how do I write to Discord? And the problem is that like it spit something out, and every time I would ask it, basically, it would give me a different way of doing it. And I'm like, why is it giving me different ways? I'm like, okay, sure, there's probably different ways in the Discord documentation, but essentially what I ended up doing was just copying and pasting one of them that worked, okay? And I think this is an absolutely horrible way to develop because I didn't actually understand anything about how the Discord API worked. Did I get my project working? Sure I did. But did I have any transferable skills or any knowledge that I can apply later of how Discord API works? What are the differences between the two different methods? Why one is better than the other? I knew nothing at that point. So I was like, this is maybe good for initial discovery just to see what's out there. But I am not a fan of using ChatGPT and like all these things and Amazon Q and all these other LLMs to basically expedite your development. I think you're actually shooting yourself in the foot in the long run. You're getting the task done, but you don't actually have the understanding of what is happening behind the scenes. And that's not going to make you, that's short-term gain for long-term pain. You're going to be able to figure out what you need to figure out. Fantastic. But in the long term, if someone asks you about like, hey, why did you do it this way? What are you going to say? So in my opinion, all these LLMs are great if you already have some context of what you're trying to do. How I've been using them lately is like CDK is a good example. I already know how CDK works. I know like what the capabilities are. I've read like almost all the documentation. I know certain things exist. So I'm like, okay, I can't remember the exact syntax. Can you just tell me how to create an EC2 with an ALB in front of it? And then I'll just move on instead of having to go through the documentation. And also other stuff like, we write a lot of Java. So like, I know there's a lot of libraries already that can do some very specific things. And so I'm just like, hey, what's the specific function to do this thing that I'm trying to do? It's fantastic for that. I plan on making a whole video about this in a couple weeks because I'm kind of annoyed, but that's just kind of what I think of Amazon Q. Sorry, kind of went off on a tangent there. Do I still work at Amazon? Thoughts on RTO 5 days? Yes, I still work at Amazon. I am not happy about RTO 5 days. I think that's the general sentiment. A lot of people on my team are upset. A lot of people outside of my team are upset. I don't want to talk about it. I guess it is what it is. Okay, let's time box this to another like 5 minutes or so because I want to move on to the Lambda doc. Custom charts, who cares? This is repetitive. I've already seen these things. Image component, layer map. Okay, let's just scroll down a little bit. Chat customization. I think this is where I left off. JSONata. RTO means return to office. For those of you that don't know, RTO is now being forced among Amazon employees. Previously, it was 3 days a week in the office. That was tracked by your manager. And now it is going to be 5 days as of January 2nd, I believe. Yeah, it sucks. A lot of people are pissed. Okay, there's too much noise here, to be honest with you, in this website. I've actually never used this website before, but there's just like way too much stuff. And maybe that's a reflection of AWS actually. So not necessarily the author's fault. Anyways, let's move on. I want to read this blog post, which caught a lot of headlines lately. This is by Werner Vogels. It's on the website, allthingsdistributed.com. Werner Vogels is like the CTO of AWS or something like that. I can't remember exactly what his specific role is, but he is a head honcho over there. You'll see him at reInvent. He does a lot of announcements, but he's talking here about Lambda. Just turned 10, so 10 years old. And honestly, Lambda changed the game. Serverless is huge these days. We use it extensively at work. A lot of companies use it at work for their functions as well. It's really changed how, sorry, I'm just reading the chat. It really changed how we just write software applications and think about them. Guezgo asks, have you tried C-Line or Cursor? Cursor I've tried. I really like Cursor actually. Cursor is the better one. It's just you have to pay after a certain period of time, which whatever. It's probably worth it though, considering how good it was. Cursor is like, for those of you that don't know, it's a fork of VS Code, but it's got LLM capabilities. And the reason that I think it's better than Q is that it's just got a better user experience, to be honest. It's got like similar functions as Amazon Q, but you can do like a lot of things inline. You can refine the output directly inline. There's a bunch of things I like about it, so you should check it out. Okay, let's get into this. For those of you that don't know, why this is a funny image is because when you're at Amazon for 10 years, you get a red badge. So that's what he's kind of poking fun at here. Okay. One of our strengths at AWS has always been our ability to get primitives into the hands of our customers and observe what they do. True. They always are trying to kind of experiment quickly and seeing what people do with the solutions they build. In nearly every instance, someone uses these building blocks in interesting ways that we didn't expect. Sometimes it's domain-specific innovation, but other times it's customers working around the limitation of what's available. When the latter happens, it's a signal that we need to provide new primitives that enable this pattern, to make it simpler for our customers and abstract away complexity. AWS Lambda is a perfect example. I have some comments on this already, but I want to get to the end of this paragraph. We saw that customers had entire EC2 fleets sitting idle, waiting to run simple functions like writing to a database or processing a file. It was inefficient, and we knew we could do better. So we challenged ourselves to build a service that allowed our customers to focus on their unique application logic, not on the undifferentiated heavy lifting of provisioning servers, auto-scaling, patching, software, and logging. And it started with a doc. So yeah, this is 100% true. So to give you an idea of how things used to work, at least internally at Amazon before Lambda existed, we used to use all EC2 instances for everything. And there's a new, or sorry, not new. There's like a legacy setup where you didn't actually interact with an AWS account. You interacted with a tool that kind of proxied into an AWS account that managed the EC2 instances for you. But this kind of thing happened all the time. Like you had an event processing application that was listening for events, processing them, throwing them in a database. You had to provision EC2 instances. And if your customer traffic or your workload, let me actually make more room like this. So you had, I don't know, a workload that looked like this, right? Spiky. And this is very standard, by the way. You see this in like every application, or not every application, a lot of applications. You would have to provision enough resources basically for the peaks, right? For the peaks. And then, you have to take into account scaling. Like what if, in the future, this would go like this, right? Or have like much higher peaks. I hope you guys can still see this. Yeah, you can. So then you would need to, at some point in time, decide this and like kind of go up here. And then like everything here in the shaded area, right? Everything here is pretty much waste, right? So you can use auto scaling policies for this, but we didn't always have access to it in the beginning, the early days. So that's kind of what you would do now. But for an event processing application, this is a whole lot of waste for any application really that wants to respond to some workload. There's a ton of waste here. So Lambda made this a whole lot easier. That's essentially what he's saying here. So completely agree. And it started with a doc, he says. As an Amazonian, regardless of role or seniority, there is an expectation that when you have a good idea, you'll put pen to paper and craft a compelling narrative. Very true. Amazon is a very writing-heavy company. I've become a much better writer over time. Part of it through just experience of writing, but part of it being deliberate. I've actually made a couple videos on books that are very, very helpful, that have made me a better writer. So you can check that video out. I think it's like top books for software developers or something on my channel. I actually have a bunch here probably on my bookshelf. One is called The Pyramid Principle by Barbara Minto. The other one, I really need some kind of organizational system. Oh, here it is. I see it. Hold on. There's two. I don't know if you guys can see this. Right here. It's called On Writing Well by William Zisner. I don't know what his name is. Really, really good book. Easy to read as well. This one's kind of interesting too. It's by Stephen King. I don't know if you guys have ever seen this. Really good book too on how to write. Justin says, Chris Lang says, any news? Oh, my camera. What happened to my camera? Is it gone again? Sorry. Hold on, guys. Let me fix my camera. You can see any of that? Oh, man. Are we back? Did it work? Yeah, we're back. Okay, here's the Stephen King one on writing. It's called. Really good. Here's the other one. I don't think you saw it. On Writing Well. Check it out on Amazon. They're pretty cheap. They're good. Justin says, I was working on implementing a Kia DHCP service in Amazon for my team, and apparently there's an S goal to not use RDS DBs. Thoughts? Org only likes NoSQL. I think that's true for tier 1 services. Tier 1 being stuff that like can't go down. And it's mostly because people don't, like, multiple reasons. You need like a DBA or database administrator to help you with SQL query planning on RDSs. So that's like another job that you don't necessarily want to have to, I guess, Amazon to pay for. And like NoSQL just manages this for you at the cost of reducing your potential for what you can do with your database. But there are some like very clear reasons to use SQL. I'm actually using them for one of my applications at work. So I don't know about this S-team goal. It's not tier 1, it's tier 2, but it's something that is very obviously SQL. Like SQL will work better. It has relations. It has constraints that we need to uphold, things like that. Anyways, let's keep it going here. Let's not get too off topic. These docs take many forms: 1-pagers, 2-pagers, the infamous 6-pager, and of course PR FAQs. A press release followed by frequently asked questions we anticipate our customers will have, or that of our internal stakeholders. These press releases are internal tools not shared broadly, designed to ensure that we clearly define what we will deliver for customers. And while each of these docs has a different purpose, the rationale remains the same. Writing forces the author to be clear, precise, and detailed, to string sentences together, take a position, and support that position with data. Oh, this is well written, actually. It's giving me goosebumps. It places the burden on the author to avoid anything confusing or that could be misinterpreted by the reader. It's hard work. I've never seen someone get it right the first time. True. It takes collecting feedback and revising and then revising again, but a good idea backed by a crisp doc has proven it can produce wonderful products. It's something we've seen over and over again, from one-click buying at Amazon Prime to the launch of AWS and Kindle. So today on Lambda's 10th anniversary, I'd like to share the PR FAQ that's launched one of AWS's foundational services. It's been slightly modified for length, repetition, and readability, but it provides a peek behind the curtain at the customer problems we were observing in the early 2010s in our vision for serverless compute. Well-written paragraph, I might say, Werner. Well done. Okay. Let's keep going. Lambda, driven by the needs of our customers, has evolved quite a bit in the last decade. It certainly has. They've added a whole bunch of new features, provision concurrency. What else have they done? Integration with CloudWatch log insights, tons of new settings, new integrations. It basically hooks into every service these days. It's pretty wild. When you read this PR FAQ, you'll notice some things that have changed. For example, 1 millisecond billing. This was a really big one last year that saved people a lot of money. And support for functions with 10 gigabytes of memory and a handful of ideas that eventually turn into full-blown features, which I've annotated in the text below. It's a reminder that while we try very hard to be thorough, we are not omniscient. And the goal of writing is not perfection. The goal is to get products into the hands of our customers, watch how they use them, make adjustments, and innovate along the way. Very true for writing. No one starts great at writing. If you work at a company that doesn't really have a writing culture, I encourage you to think about it. Writing design docs is a really effective way to kind of tell a story about what you're trying to solve, what the problem is, what the customer experience is going to be, and how you're going to solve it through text. So really helps bake out all the details that you need to think about usually in advance. Something to think about if you've never written a design doc before. Someone asked, any idea when AWS will support auto dead letter queue redrives? No idea. Mark Brooker, I don't even know if that's a good thing, actually. Auto DLQ redrives. I think it's good to keep it separate, to be honest. Because you already have retries available, right? When you have SQS, for example. Like multiple retry attempts, but we'll keep that aside. Mark Brooker, who's I think a senior PE at Amazon, principal engineer, put it quite brilliantly on a recent episode in AWS Developer Podcast that he's paraphrasing. The idea is that our customers have always come up with unexpected use cases for services like Lambda, things that don't make it into a PR FAQ. As engineers, we love this because it challenges us to innovate and think bigger and more broadly for our customers. And it's the driving force that has led to a range of innovations such as SnapStart, Firecracker, and containers. The constant pursuit to make building easier for anyone using AWS. Here's to 10 years of Lambda and to all the ways you've used it to solve complex problems and push the boundaries of serverless computing. Cool. All right, let's get into it. So this was written November 2014, an eternity ago. Okay. Amazon, AWS, blah, 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 announced the introduction. Okay, by the way, let me preface this with saying that they write these docs to convey an idea. Okay. They're writing it as if the thing already exists. That's what a PR FAQ means. Like it's a press release, frequently asked questions, right? So it's about what is this application that we are going to build? And we're writing it under the assumption that it's already out there in a wild. So it's going to talk about like aspirations and goals and what this thing could be and what customers will be able to do with it. Okay. So none of this existed at the time that they actually wrote this thing. This is all future looking. Okay, just wanted to lay that out there. They announced the introduction of Lambda, the simplest way to run code in the cloud. Previously, running code in the cloud meant creating a cloud service to host the application logic and then operating the service, requiring developers to be experts in everything from automating failover to security to service reliability. This was such a pain. Like it was so terrible back when I first started at Amazon there. All the stuff you had to worry about, all the campaigns because your instance needed patching, security stuff was a pain, everything was a pain. Lambda made this so much easier when it got launched. Like you don't have to worry about any of this stuff. Okay, Lambda eliminates the operational costs and learning curve for developers by turning any code into secure, reliable, and highly available cloud service with a web accessible endpoint within seconds. Lambda uses trusted AWS infrastructure to automatically match resources to incoming requests, ensuring the resulting service can instantaneously scale with no change in performance or behavior. This frees developers to focus on their application logic. There's no capacity planning or upfront resource type selection required to handle additional traffic. Is this really true though? Like you have to pick memory, right? Which is a proxy for, I guess, resource type and CPUs and all that. There is no learning curve to get started with Lambda. It supports familiar platforms like Java, Node, Python, and Ruby with rich support for each language's standard and third-party libraries. Lambda is priced at X for each request and Y for each 250 granularity. Wow. That's pretty coarse of execution time, making it cost-effective at any amount of usage. To get started, visit Lambda, blah, blah, blah. What did Werner say? The serverless model introduced the idea that customers would only pay for what they used. With Lambda, we were able to build on this model, only charging per execution. Above, you can see that the goal was to charge per 250. I noticed that. But by launch, we brought it down to 100. I didn't even know this, that it was 100. I thought it was it always 100? I swear it was less, right? Now we just take it for granted that you get per millisecond billing, so I don't even know. It's an area where we really push to reward customers for their optimization efforts. And today you can execute a Lambda function you are billed per 1 millisecond with no minimums. Very nice. Lambda has enabled us to deliver so this is a quote. Usually you'll see this in PR FAQs. It's kind of a perspective of a customer. So keep that in mind. Lambda has enabled us to deliver a world-class cross-device photo sharing app, says the CTO of XXX. We had great success with our app on iOS, hitting 1 million downloads in 3 weeks, which led to huge demand for the Android version. As we considered ways to leverage the cloud to make our app cross-platform, we chose Lambda as the cost-effective choice to host our critical image processing logic. The support for JavaScript and Git made it easy for us to get our backend app and running within a few days. Previously, we would have incurred a huge management and operational overhead to maintain our user promise of fast and reliable response times for our customers as they access their pictures. With Lambda and AWS, we know we have the scale, stability, and performance to support our customers, even in periods of unpredictable demand. Except for the poor bastard that gets the cold start, right? Okay. Using Lambda is simple. Developers express their application's logic as they choose. As a one-line Python script, a Java application using native libraries, or even a binary executable compiled from C or C++. When ready, developers can upload their code as a zip file, point Lambda to the repository, or author code directly from any browser using the AWS console. Lambda makes it easy to write code that securely integrates other AWS services with built-in support for AWS SDKs and automatic integration with AWS IAM and Cognito Identity Broker. Did Cognito even exist at this time? Who knows? Lambda turns code into a secure, highly available service within seconds that can be called from any connected device or app and requires no code or configuration changes to handle additional traffic. The best part. Developers retain full visibility over the functional and operational performance of their code by monitoring their service using the AWS Lambda console and troubleshooting issues using CloudWatch logs. KVS says your videos are helpful. Thank you, bud. What did Werner say here? We made the hard decision to only launch support for Node, which was popular at the time. This allowed us to validate our programming model, observe how customers were using Lambda, and use those learnings as we added support for additional runtimes. And support for zip files was also a big deal. Without zip, builders would have to add files individually. This still happens from time to time when I use the AWS console to just put together quick scripts for Lambda. Instead, they could package up the necessary dependencies in Lambda handler, upload it, and the function would run. It was a simple feature that made things much easier. Now they've also introduced Docker images as well for this, so even better than before. So you can use a Docker image as opposed to like a zip file, and then you can put your image on ECR, Elastic Container Repository, and then it links there. So you can like run it on your local dev machine as if it's in a Lambda function, then just like upload that image to Lambda and it kind of takes it away. Another quote. Lambda has been an accelerator for my team to port and launch multiple services as we embrace the cloud, says head of corporate development. We have been using Lambda for everything from automating instant account balance updates based on customer trade notifications to running nightly backups and scrubbing of transaction data to S3. Handling a mix of internal and external users typically presents security challenges, but Lambda incorporates a lot of AWS best practices and controls that makes it just as easy for us to securely connect to our data stored in AWS as well as our internal services. In the past, managing our infrastructure has gotten in the way of quickly iterating on what our customers and internal users want. With Lambda, my developers don't have to be in the business of operating production services and can focus on quickly delivering differentiated business functionality within hours and days, not weeks. Lambda has also ensured my team hasn't given up anything in terms of tuning performance and debugging capabilities by going with a provider. I don't know about this because in the beginning, CloudWatch logs combined with Lambda was a massive pain in the ass, especially if you had a really high throughput application. It was almost impossible to look through all of your log groups to find a specific invocation that you were looking for. This is actually my big complaint of using Lambda in the early days. Now this is solved with CloudWatch Insights and CloudWatch Tail, or CloudWatch Tail log tail. That's what it is. Before, Lambda obviously delivers all your logs to CloudWatch, but for every container that it runs behind the scenes, it will create a different log stream. And then if you have a high throughput application with many concurrent executions, you're going to have dozens of log streams to look through to try and find like a specific execution. The other thing to know about Amazon is that sometimes a lot of times you have tickets that you need to debug or you get escalations and it's like, why did your system do this specific thing at this specific point in time? So you're looking for a very specific invocation at a specific moment. This was a nightmare before. It was so hard to do. There was a feature in CloudWatch logs to look through all log groups at once, but it never worked, almost ever. So what I had to do is like go through every log stream at around the time that I knew the thing happened and then try and find it. Massive waste of time. So I would debate debugging capabilities as a selling point of Lambda. Love the new AWS console UI and much needed Lambda code editor. I love the UI as well. I've actually been using it for months. It was released internally at work a while ago. If you don't like it right now, I've grown to like it. It'll grow on you is what I'll say. And what else did you say? Yeah, the Lambda code editor is a big improvement too. I made a video on that one, I think. Okay, Lambda charges for the total number of requests an application handles and the resources it consumes in units of 250 ms and GB, so developers pay only for what they use without the complexity of commitment of upfront reservations. Lambda is cost effective at one request or thousands per second, all with the same customer code. Interesting that they were thinking about like this massive order of scale from the beginning. But yeah. Developers can wire up any application, script, or process to execute when needed, confident that there will never be a charge for idle time. Short-lived tasks where the scale changes rapidly, and periodic tasks are as cost-effective as steady-state workloads. Is that true? Maybe that's the goal, but that's not how it turned out. It's not as cost-effective for steady-state workloads. You can do the math yourself. You're much better off using ECS or something for steady state. I don't know what happened here. Maybe this was a goal, didn't pan out. The cost calculation didn't really work out in their favor here. Lambda is available immediately in all regions. The first blah, blah, blah requests and YYY seconds are free to all users. For pricing details, visit Lambda. Cool. So this is pretty typical, by the way. Like the length of this is 1 to 2 pages, probably 1.5 or so. This is actually a really well-written PR FAQ that I've seen. If you're looking for a good writing example, this is one. So go and check it out. I think I already shared the link. Did I? Yes, I did. So you should have this. Let's just check out some of the FAQs really quick because this is really long and we're not going to get through everything here. Let's check out like the top couple. What is Lambda? Secure, reliable, and scalable service for running stateless applications in the cloud. It's a deal for developers that just want to run some code but have limited expertise or investment in cloud operations and do not want the management and operational overhead of owning a server pool. Lambda manages and scales the servers. Okay, we know this. When we launched Lambda, security was not negotiable, and we knew that there would be trade-offs. So until Firecracker is a VM, I believe, for Lambda, we used a single tenant EC2 instances. Wow, I didn't know that. So no two customers shared an instance, and this was expensive. Yeah, I would think so. But we knew that long-term it was a problem we could solve, and we trusted our developers to deliver. These days, we can securely pack thousands of micro VMs onto a single bare metal instance. It's a reminder that innovation doesn't happen overnight and that meaningful change is often incremental. As Jeff Bezos said, if we're going to do anything new or innovative, you have to be willing to be misunderstood. And if you're not willing to be misunderstood, then don't do anything new or innovative. This must have been insanely expensive in the beginning. Single tenant, for those of you that don't know, just means that one customer, or I don't know if they mean customer or Lambda function itself, one customer or Lambda or application per EC2 instance. So you have 10 customers, then 10, and they all have Lambda functions. They're all on separate EC2 instances. But it's not exactly clear what they mean by tenant here. Is it customer? Is it application? Is it function? Like, what does that mean? But either way, it's expensive. Some of them more expensive than others. Who should use Lambda? Sorry, I'm just getting caught up with some of the chat questions here. Why does Lambda have a timeout of only 15 minutes? Why not support dynamic timeouts out of the box? Don't know. Probably something to do with their architecture. I imagine they're trying to increase this since this is a popular ask. Another question. I had an issue with Lambda recently that took so long to figure out. The socket timeout is so low that I didn't keep a connection when I used Boto3 from Airflow. Yeah, sometimes you need to change the default configuration settings on the clients that you use within your Lambda function. So like the Boto3 client that calls an AWS service, you can customize like wait times and timeouts and retries and all these kinds of things. But most people just take the defaults, but it is something to consider because it does lead to bugs, or not bugs, but errors that you have to figure out and fix. Where were we? Do not require the investment, blah, blah, blah. Lambda targets ease of use and developer productivity by defining a standard operating system and language runtime versions. All developers provide their code and any non-standard libraries it needs. Lambda abstracts away the operational aspects of running code in the cloud. So developers don't think about selecting instance types, cross-availability zone failover, or patching the operating system runtime or libraries, while still benefiting from the security, scalability, and availability. Okay, this is not that important.
skip it over. I think we probably already know this by now, or most people already know this, but we can kind of skim it. It can be used to host any application, regardless of traffic, language size, that don't require highly customized environment, long-lived state, or persistent database connection. Applications store any persistent data in services like S3 or Dynamo. It can be as simple as a single line of code. You can create handlers, blah, blah, blah. Authoring new applications is easy because it's written in familiar languages and uses existing libraries, including the built-in AWS SDKs. What else they got here? Okay, some stuff on developing and deploying. What did Werner say? In 2020, we added container support for functions. This is what I was talking about earlier. This not only made dependency management easier, but also gave builders the ability to use familiar containerization tools and move beyond the 250 megabyte function limit to deploy container images up to 10 GB. For those of you that use Lambda for like ML applications like PyTorch and forget the names of the other ones, but some of those dependencies are huge, like far beyond 250 MB. So this is actually a really good thing when they introduce this. Serving large container images as functions without incurring additional latencies was no mean feat. Oh, was no mean feat. Okay, so hard. I suggest watching Mark Brooker's 2023 talk on on-demand container loading at blah, blah, blah to learn a bit more about how we do this. I may look at this later. Let's skip over this and just look for Werner's thoughts. What is he saying here? Because Lambda uses stock versions of the language runtimes and standard libraries, developers can easily develop, test, and debug their code on desktop or their running EC2 instances with the same environments. This got a lot easier. He says this got a lot easier with the SAM, serverless application model, which launched in 2020. True? Here's the bug. The Lambda function would restart itself every time the socket timeout. It would loop until max runtime equal 3 minutes. There was an infinite loop. Oh, that's horrible. What languages and libraries does Lambda support? It supports Java, JavaScript, Ruby, and Python. Yeah, he's just talking about the language release timeline that they saw. What if a library I don't want to use isn't available? They can bundle third-party libraries. And what did Werner say? Well, we didn't know everything our customers would try to build with Lambda. We knew that we needed to provide support for native libraries. Whenever an app takes dependencies, there's a non-zero chance that a dependency relies on a native library that the builder may not have thought of. And so we made sure to include those in the runtime. In 2018, we launched Lambda Layers, which gave the builder the ability to create version layers of reusable code, custom libraries, or even vendor-provided layers for things like application monitoring or security. Interesting. What does he say here? They're saying, how do I invoke my Lambda application response to a DynamoDB update? They were thinking about this in the beginning, huh? What is this? Use Amazon DynamoDB's set table handler API to identify the table to track and Lambda application to invoke when the table's content changes. After that, every successful write to the table in question will trigger the corresponding application. So this is DynamoDB streams. Those of you that use Lambda triggers for S3 events and DynamoDB streams will notice that this became much simpler than it was originally laid out in the FAQ. By the way, if you don't use DynamoDB streams and you use Dynamo, you're missing out. How long can applications run? I think someone was asking about this earlier. I think it was originally 5 minutes, right? Applications initiated by an HTTP request must complete within the request lifetime, typically within 30 seconds, although they can invoke batch jobs. What did he say here? Applications representing batch and time jobs are terminated after approximately 4 hours? Interesting. Wait. It's definitely not 4 hours. I don't know what he's talking about with the batch jobs thing here. I don't know. I'm just going to skip that one. What was the latency of invoking an application using the Lambda API? Something in the range of 20 to 50 ms. Just using a simple echo application. Yeah, see, latency would be higher the first time an application is deployed and when an application has not been used recently. This is cold start. Improving latency is something that we have worked at continuously for the last decade. Innovations primarily enabled by using Firecracker micro VMs led us to launch Snapstart in 2022 and reduce cold start latency, especially for Java functions. Snapstart, if I remember correctly, is the idea where it takes a snapshot of your your memory state at a certain point in time. And then when the function invocation comes in, as opposed to having to reload the entire context, it just reloads that context of memory directly. So there's no like boot up process. So reduced cold start latency for Java functions by up to 90%. This is a sales number. I don't know how true this is. I feel like it's a lot lower in real applications. Moving along. Hold on, I want to read this one. When would we direct a customer to not use Lambda? Interesting. Mobile backends and any AWS service embedded scripting uses, such as custom CloudWatch actions or custom video transcoder rules, will use Lambda under the hood. Customers with these use cases will implicitly select the service. Okay. AWS event handlers and batch cron jobs where the job is readily expressed as an application are good targets. True, which will offer the customer convenience and simplicity versus setting up their own instances, and where the service can complete jobs quickly by offering nearly unlimited burst capability to run many applications in parallel. At the same time, Lambda will be cost-effective, compacting jobs onto the minimal set of EC2 instances, selecting the instance types to minimize customer cost, and avoiding any charge for intra-hour idle time. Customers with these use cases should use Lambda. Customers with existing applications, lift and shift, those who want access to the underlying EC2 instances, who wish to write in languages other than those supported by the service, or who need stateful code cannot use Lambda and should use Beanstalk or EC2. They don't talk about APIs here though, right? I typically don't use Lambda for API-based services. Not something they talk about specifically though. Interesting. What is this? Tenets are guiding principles that shape a team's decision-making process and overall strategy. Okay, so yeah, you guys can read through this if you want. You'll find them in almost every doc. Tenets as a guide for us as the product inevitably evolves. They keep us honest with ourselves and help simplify decision-making when reaching consensus becomes challenging. What else has Werner said here? That's it. That is it. Okay, so this was a good read. Kind of an interesting historic lens into what Lambda was intended to be when it first was conceived. I think we can all agree that it's really changed how a lot of us develop applications, specifically in event processing and like just writing some simple scripts to do things on the cloud. Just makes our lives a million times easier. I personally it's like one of my favorite services in AWS, if not the favorite that I have. I have courses on it. I talk about it ad nauseum. It's very, very heavily used all across the industry, within Amazon, outside of Amazon. Doesn't matter where you look. Anyone that uses AWS needs to know about Lambda. So I hope you guys enjoyed this video and this live stream. I'm probably going to kind of bundle this into a video so that folks can watch it specifically for this component, the Lambda article review. I can take any questions now if anyone wants for maybe 5 minutes or so. Why don't you use Lambda for APIs? Cold start latency is the answer. Let me draw. Basically, what happens is that you have a person, right, that is using their computer and they are like on some website, right? And that website hosts some REST API that could be backed by a Lambda function, right? By a Lambda function, which has your code inside of it, right? So they make a request to your Lambda function. And the way Lambda works is that when you have periods of no requests that are coming in, so say, for example, think of like first thing in the morning, right? No one has logged onto your website. This is customer number one, okay? They hit this application. They try to place an order, for example. Hits your Lambda function. There's no VMs that are behind the scene. VMs mean like virtual machines, right? So there's no underlying VM that is up and ready to actually receive the traffic, right? So when this request comes in, your customer now needs to wait for Lambda to spin up this VM, make it available, then run your code, then return it back to the client. In different programming languages, the duration of this process can be long, especially in compile languages. Like Java is notoriously bad at this. Some other languages like Python and JavaScript are pretty quick, so this is less of a problem. So what happens to this customer, right? They tried to place an order and their thing times out. And now if you don't have idempotency, like bad things may happen if you ran multiple different Lambda functions prior to this or different processes prior to this. So what this essentially translates to is bad customer experience for the first customers that are using your application and calling an API. Now, if you have if it's service to service, where you have like one service that's hosted with a Lambda calling another service that's hosted with a Lambda, this isn't a big deal, right? If this fails, you just retry and things carry on as usual. But in cases where you have actual customers that are waiting for a response, like someone sitting at the other end of this, like this isn't a really good thing. This same scenario, by the way, also applies when you have like multiple customers that are making calls. So only one Lambda instance was spun up to service this request. But what if you had two people that were making a request at the same time, right? Lambda won't necessarily reuse this container. It will, for any concurrent request, it would need to spin up a second container, which is why if you look at AWS log streams, you'll see one entry for this VM and one entry for this VM, because concurrency determines how many containers that you have available. This can be mitigated with provisioned concurrency. And what provisioned concurrency essentially means is that it keeps these VMs running. If you use this feature, I will ask you, why are you using provisioned concurrency? And why are you not using just a normal EC2 instance? Because they are effectively the same thing. This is much more expensive. This is less expensive. This requires no security configuration, no maintenance, no management, essentially at all. This requires some. So the question is, what do you value more? Money or time? You can convert money to time because it takes time, which costs hours in the day for your developers to fix these things and manage and deploy hotfixes and patches and security and all that crap. But a lot of people might prefer this model, right? And this is the nice thing about AWS in general, is that there's a lot of different options, right? If you want the full fine-grained control over everything, go with EC2. If you want levels of abstraction, go with Lambda, go with AppRunner, go with ECS. There's a lot of different knobs that you can turn and services that you can select from. But one thing that I will say that, and this is for those of you that are still learning AWS, is that there are building blocks in AWS. Core services that are extremely, extremely important, that are basically the foundation for everything else that you see. I meant to make a video on this topic because it's kind of important to think about, but there's like bottom level services, right? These are the building blocks, and you can think of it literally like a pyramid, right? EC2 is one. S3 is one. SQS is another one. SNS is another one. DynamoDB is another one. Step functions. I'm a little bit hand wavy on step functions. I may not put it in this category. These are some of the most important AWS services. I'm probably missing one or two, but it's fine. All these other services that you see, things like, ECS, AppRunner, EventBridge. What else? Elastic Beanstalk, which no one should probably be using these days. These all sit on top of the foundational services.
They are abstractions for the foundational services. So how is ECS implemented? It's probably a combination. It definitely uses EC2, probably uses ECS in some capacity, probably uses DynamoDB to store the state somewhere of like how this thing is managed. But that's what you need to understand. So a lot of people will go and like try to skip things, right? They'll go like to a layer really high, right, in this. And you can kind of add multiple different layers of services here. The ones with high abstraction are way up high, right? Or way up at the top. So high abstraction. So the further you go up, the higher it gets. High abstraction. And conversely, the ones at the bottom are low abstraction. So you need to deal with the details. If you're learning AWS, you need to learn these first, because this is what everything else depends on. Once you have a solid foundation of this, then you're pretty much good to go, and you can understand anything else on top. Oh, I missed VPCs. VPCs is another one that sits at the bottom. So I call these like AWS building blocks because they're so important. So just keep that in mind. Something worthwhile to think about. Anyone else have any more questions before I sign off? This is the final call. I think we've been going for how long? I don't know. Doesn't tell me on this thing. No more questions? Okay. Well, thanks everyone for tuning in. I enjoyed this. If you guys like these live streams, let me know, by the way. I'm open to doing them more often if folks enjoy them. But yeah, thanks so much for tuning in, and I'll see you in the next video. I do have a lot more stuff, by the way, coming out next week and the week after as we approach reInvent. So I'm going to be doing a lot of AWS news updates in this kind of similar format, like what I'm drawing. I'm kind of trying out this new drawing format too, as opposed to using PowerPoint and Adobe After Effects for animations and stuff. It's a lot more informal. It allows me to make a lot more videos as opposed to fewer videos that are like super, super refined. To be honest, I like getting the breadth, talking about a lot more things as opposed to fewer things of super high quality. So let me know what you think about that, by the way. Anyways, thanks so much, everyone. I'll see you in the next one. Have a good day. Bye.